All right, so let's do another example. And so this example looks a little different because this is a definite integral instead of an indefinite integral. And we'll talk about how to do that, like what to do with that in a minute. But first, we're just going to proceed like normal, basically. So we're still looking for a composite function, and we're looking for the derivative of the inside function multiplied somewhere else. And so looking at this integral right here, we can kind of see that this x squared minus 3x plus 1, that's on the inside of a square root. And so that's one indication that that's going to be our composite function. And then another indication is that we want the derivative of x squared minus 3x plus 1 multiplied somewhere else in the problem. The derivative of x squared minus 3x plus 1 is 2x minus 3. So that's a really strong indication that that is right. So we're going to write down u is equal to x squared minus 3x plus 1. And so then du is equal to 2x minus 3 times dx. Great. And so then what we're saying is that, this down here just on the inside, that's our u. And then this up here is our du. So this is our du. And so if I rewrite this, this is going to be the integral from, well, just the integral. And then we have du on top, and then the square root of u on the bottom. And then it's really tempting to just bring over the 3 and the 5. However, that's not right. And why that's not right is because this entire integral, this first one, is in terms of x, and we want this entire integral to be in terms of u. And these are x values, so this is saying from x is equal to 3 to x is equal to 5, and we need to write down u values for our bounds. And we have a relationship between u and x, and we're going to use that relationship to write down our new x values. So we're going to say that 3 gets turned into 3 squared minus 3 times 3 plus 1. So that's going to be our u value. And this is 9 minus 9, which is 0, plus 1 is 1. So our x is equal to 3 gets turned into u is equal to 1. So we're going to put that on our lower bound. And then the 5 gets turned into 5 squared minus 3 times 5 plus 1. And so this is 25 minus 15 is 10, plus 1 is 11. So this is equal to 11. And so our upper bound, 5, gets turned into an 11. Great. So now we can proceed like normal, basically. And so let's rewrite this. So this down here is u to the 1/2. And so let's actually rewrite it like that. So this is the integral from 1 to 11 of du over u to the 1/2. And then that is going to be equal to, we can bring up this u to the 1/2 up top as long as we make our exponent negative. So this is the integral from 1 to 11 of u to the negative 1/2 times du. And now we can just do our power rule. So this is going to be u to the positive 1/2 divided by 1/2 or multiplied by 2 is the same thing. And then we're going to evaluate this from 11 to 1. So then this is going to be 2 times the square root of 11 minus 2 times the square root of 1. And so then so the square root of 1 is just 1. So this is going to be equal to 2 times the square root of 11 minus 2. And that's it.